I am going to explain some more chemical properties. And in this, the first point is reaction with hydrogen. So that the formation of hydrides, directly or indirectly. So members of this family forms trihydrides. Trihydrides means 3 hydrogen atoms are attached. Trihydrides having general formula. General formula, a formula which represents, so it will be, ES3, E for the element, ES3. Trihalides, like NS3, then there is PS3, S3, SB, S3, and BIS3. These are the trihalides of the family. Trihalides. This is ammonium. The trihalide. Then this is phosphine. This is arsenic trihydride. This is antimony. This is bismuth trihalide. Then we will see about the very important point about their physical and the chemical character. See how. Now here I have written. So this is list of the 5 hydrides. So here first point is the stability. Stability, or more accurately thermal stability, means the behavior towards heat. So as we move from top to bottom, atomic size increases. So thermal stability decreases. So it decreases down the group. Decreases down the group as the size of members. Members means this is the 15 members. Size of members increases, and hydrogen atoms are bonded by poor attractive forces. So the general trend will be this NS3, it will be most stable, followed by PS3, followed by arsenic trihydride. Arsenic and bismuth, arsenic, antimony, bismuth, they are very close to each other, and it is much less than that of the bismuth. Now see this bismuth, it is highly unstable, metallic, size is largest bismuth, and so it loses. So this is the about the thermal stability. Now this is very important point. Reducing character, reducing character means ability to provide the hydrogen. So as stability is there. So reducing character. So this NS3, it is very strongly, very strong. Then this, then coming to and so this BIS. So reducing character increases down the road. There is the increase in reducing character. There is increase in the reducing character. Why? Because of the bismuth has larger size. Nitrogen is smallest size. So in this, the hydrogen atoms are bonded by very strong force of attraction. Here, hydrogen atoms are attached by with the bismuth very poor force of attraction. So this is about the reducing character, and so it increases down the group. Now coming to basic character. So basic character means the more precisely Lewis base. So nitrogen all have a lone pair of electrons. All have lone pair of electrons. But the size of nitrogen is very small, and size of bismuth it is largest. So a pair of electron or the two electrons are present on this, present on this, but size of this nitrogen is very small, smallest. This is largest. So the electron density will be maximum on the smaller nitrogen. Electron density is scarce, means scattered on the largest bismuth. So it decreases down the group. It decreases down the group due to increase in atomic size. Atomic size, it increases, and electron density, spreads. So train will be this NH3, it will be most basic, followed by PS3, then S3, then S3, and bismuth, it is very large, so it will be almost same, and so this is general trend about the basic character. Now coming to next point, reaction with oxygen. So members of this family forms oxides in two categories. It is said to be trioxide, and T2O5 is said to be penta oxide. So our first point is that the elements in the higher oxidation state are, they have different character. They have different character than that of lower oxidation state. They have different character than that of lower oxidation states here. The oxides in the high oxidation state. High oxidation state are more acidic. They are more acidic, because they have increasing metallic character, so they hold the hydroxyl ions, and the hydrogen ions are lost easily. So this is there. Now the trioxides are of much more important. Now the trioxides of nitrogen and phosphorus are they are acidic. And of this arsenic and antimony, are amphoteric. While bismuth trioxide, it is basic. Bismuth is typical metal, so this is the trend. Trioxides, nitrogen, phosphorus, very small size, so they attract the, they are acidic because they attract the, hydroxyl ions, and so they lose the hydrogen. So arsenic, antimony, they have intermediate size, so they can act as acidic as well as basic. Bismuth larger size, so bismuth, oxides, they are basic in nature, larger size, so they can attract the hydrogen, and so they are able to exhibit the basic character. Now next is reaction with halogens. So they form, halides. They form halides in the two categories, EX3 and EX5. This is trihalide. This is, pentahalide. Trihalide and pentahalide. And so, important point is that the nitrogen do not form any pentahalide. Nitrogen, it do not form any pentahalide because of the small size. As it has very small size, it has very small size is very small, and it cannot expand its octave, and so this is there. And so in case of others, there is slightly change. See, only the NF3 is stable. NF3 is very stable. Why? Because nitrogen is small size. A smaller size cannot hold the iodide ion or chloride ion or bromide ion. So this is very important point to note that NF3 is only stable, and with rest of halogens are not formed. There is not formation of any trihalide. So nitrogen do not form any trihalide like this. Now the bismuth, trihalide, it is, bismuth, being metallic in nature. So it can form. It is stable, but has covalent character. It has covalent character. Of course, bismuth, it is metallic, but it has covalent character, and it dominates. Fluorides, in most of the cases, they are water insoluble, and so this is the basic point that when there is water insoluble, so it has covalency. It is able to exhibit the covalent character. Now the last portion, reaction with metal. So general point is that all the members forms corresponding compounds in oxidation state of -3. So like nitrides are formed, then phosphides, then arsenides are formed, then antimonides, and then bismuthide. So nitrides, phosphides, arsenides, antimonides, and bismuthides, they are the compounds, and all are in the oxidation state of -3. Like calcium nitride, then phosphide, calcium phosphide also, Ca3C2, and so similarly like arsenides, and they are highly poisonous, children. You have to keep in mind overall the compounds. Very important point to note that except N2, all the elements and their compounds are highly poisonous. So this is about the general points, chemical properties of the group 15 members, and so this is all about the group.